Hello everyone, welcome to Life Sciences Grade 12. My name is Tutuzile Kupega. On the front you will see my email address. This is for when you have any questions related to life sciences. You are most welcome to send me an email, whatever questions really. As long as it's life sciences related, I'll gladly assist you. So today we are wrapping up with the topic of homeostasis. So I want us to do a quick summary of everything we have discussed this week and put it together. Then on tomorrow's lesson we will do a class activity together, which are questions I took from the textbook, the solutions for all textbook life sciences grade 12, and then we'll answer it together in class. But from next week, guys, I'll be giving you homework, so please do the homework. It will really help you check your progress on how far you are with the work, to see what you understand and what you don't. And like I said, if you reach any stumbling block, you are free to send me an email and I will engage you. So at the end of this lesson, you should know a whole summary or review of the topic of homeostasis. So what is homeostasis? To review that, we discussed in the beginning that an optimum internal environment has to be maintained for body enzymes to function properly. That we remember. Our bodies can't just survive in any state. There are specific conditions set whereby our bodies will function optimally when they're in those conditions. Ne? So another thing that is important to note about that is that there are body enzymes which are involved in those various processes in the body. So those various enzymes there have set conditions that they need to exist in for them to function optimally. And if you change those conditions, then you affect the enzymes. And when you affect the enzymes, then you affect the entire process regulated by the enzyme, which might be bad for the body. Let's mention here, the optimal level is not exact. It is not. So they exist within a narrow range. These conditions can fluctuate within a narrow range. But the body must take steps to ensure that the range is not exceeded. So suppose your body functions best at about, let's say, a blood glucose of 90 milligrams. That is the exact blood glucose concentration that is best for your body. But if it is at about 70 to 100 milligrams, then you are still fine. They are existing within a narrow range, so your body will be moving along those ranges. It will change, it will alter or fluctuate within those ranges. Ne? When enzymes are denatured or destroyed, the metabolic reactions under their control will slow down or stop altogether. So like I've mentioned, the enzymes need to be kept at specific conditions in the body. So suppose temperature, let's say example of temperature. The enzymes involved in the body will need to be regulated at a specific temperature. If you increase the temperature in the body to be way above the optimal temperature, then the enzymes there might be denatured and destroyed, which would affect various reactions under the control of those specific enzymes. The same applies for those ones involved in the metabolic reactions or in various other types of reactions in the body. If the enzymes are not working properly, the cell function will be negatively affected and the cells may die off. If the cells die off, it means even the tissues are affected, even the organs are affected. So it is very, very bad for your body. That is why homeostasis is so important. What exactly is homeostasis? It's what we've explained, what we've just discovered, what we've just discussed. The continual monitoring and regulating of the internal environments of the body. That is what homeostasis is. That word comes from a Greek word that means to stay the same. So it is doing its very best, the body is doing its very best to regulate and monitor to ensure that the conditions in the body stay the same, meaning they stay in the normal optimum conditions. If there's any change detected, then homeostasis regulation takes place, in which if there's an increase, homeostasis regulation is there to decrease and bring back to normal conditions. If there's a decrease, homeostasis regulation is there to make sure it increases whatever it is back to normal and optimal conditions. Homeostasis is therefore defined as the maintenance of a constant internal environment within an organism. So here we also discussed, and I showed you a lot of negative feedback regulation of these factors over here that need to be maintained and kept constant. It is water. We discussed water, and I showed you the negative feedback mechanism of water, and we found that the importance of maintaining or regulating water is that it is a medium for all chemical reactions that take place in water, prevents dehydration and death, and is important in osmoregulation and maintaining turbidity. And the organ involved here, mainly involved here, is the kidney. So we discussed that and how in the kidneys those hormones that are involved in regulating water, which is the ADH, right? ADH and the aldosterone. Aldosterone is there in ensuring the salt concentration, or the salt concentration in the body, those nutrients over there. So we discussed those both water and salt concentration and blood pressure are regulated in the kidneys by the ADH and aldosterone respectively for those processes over there. Osmoregulation is regulated by ADH, and aldosterone regulates the pressure in the body. And then oxygen. It affects what? The importance of oxygen. It affects the rate of cellular respiration and the rate of energy production. And we have seen the differences there where oxygen and carbon dioxide are regulated by the medulla oblongata. Carbon dioxide, the importance of that is that carbon dioxide is a waste product of cellular respiration and must be excreted as it lowers the pH. So what the regulation that happens here is that the medulla oblongata will detect the changes in the body. Why? When carbon dioxide increases, it would change the pH levels of the body, of the blood, making it more acidic. Then the medulla oblongata will detect that, and then it would increase breathing to ensure that oxygen intake increases and carbon dioxide excretion increases. So that is how carbon dioxide is regulated, and therefore that is how oxygen is also regulated. But it's important to note that the medulla oblongata only reacts to changes in carbon dioxide and not oxygen. So it only does something when there's carbon dioxide in the body is increased or detected. But if it is lower than the oxygen, then medulla oblongata doesn't react, then the body will just go back to its normal state. And then the other factor we discussed were the pH levels, which is the acidic or alkaline balance. This is also closely related to the carbon dioxide concentrations in the body. The importance of the pH level is that the maximum or optimum enzyme activity, they greatly affect enzyme activity. They must be kept at a level of between 7.0 and 7.4 for most enzymes to function. That is why as soon as there's more carbon dioxide in the body, the pH levels will lower, meaning they become more acidic. So they'll be lower than this 7.0 and 7.4, which are the optimum enzyme activity. That is why the body will then react quickly to ensure it brings the blood back to its optimal conditions. We also discussed temperature. The importance of that is that optimal functioning of enzymes is at 37.5 degrees Celsius in human beings. So if temperature is not regulated or to be kept at this constant temperature, then it is also bad for your body and will affect your body negatively, because then the enzyme function will be affected. We also discussed various ways in which temperature is regulated. We discussed the skin and the layers of the skin, the epidermis and dermis, what happens actually when it's too hot and the body wants to cool down, and what happens when the body is too cold and wants to warm up. Ne? And then nutrients. Why are nutrients a factor that needs to be regulated? The nutrients are needed for growth, repair, and metabolism. Examples include glucose, amino acids, and fatty acids. You'll remember we discussed the particular hormones we discussed here were insulin and glucagon, which are both involved in the regulation of glucose concentration in the body. If there's too high concentrations of glucose, then insulin is secreted in the body to ensure that it brings the glucose levels down. But if there is less glucose in the body, then glucagon is released so that it secretes more glucose in the body. So those two act antagonistically, or they act against each other. Those are the hormones there. Their actions are antagonistic to each other. Other factor I'll discuss, which is hormones. Hormones are involved in the regulation of almost all of these factors here. Hormones. We also discussed them you remember them from the topic of the endocrine system. Why are they important? They maintain homeostasis at the correct concentration for the proper functioning of cells. So without hormones, it would be nearly impossible for some factors to be regulated. Like I've just mentioned, with glucose, you'll need to secrete the hormone which is insulin, or to secrete the hormone which is glucagon. The same way with osmoregulation, or with the water concentration and the blood pressure, you will need to secrete either ADH or the aldosterone for those particular factors to be regulated. So hormones play a very, very crucial part in homeostasis. And then the other factor is the excretory waste. The importance of these are the waste products such as urea and carbon dioxide. They must be continually removed from cells as they are toxic if accumulated. So we've discussed here that the carbon dioxide needs to be removed and how the medulla oblongata reacts quickly to rising concentrations of carbon dioxide. Same with urea, the kidneys would react quickly to maintain those conditions. It is very, very important that the tissue fluid is kept constant at all times. This here is a diagram that shows the organs that are involved in homeostasis. The whole organs there is skin. Skin is involved where it is the main organ, the largest organ in the body actually, that is involved in thermoregulation, which is the regulation of the temperature conditions in the body. You've got what else? You have the kidneys, which are involved in the regulation of water concentration, of salt concentration, and of urea. Then you also have what? You have the lungs, which are involved in maintaining the concentrations of carbon dioxide and oxygen in the body. So they'd be involved in the excretion of carbon dioxide and the inhalation of oxygen. Then we also have the liver that also plays a very, very important role. The liver there has what we call the pancreas. There's the liver and the pancreas over there that secrete the hormones insulin and glucagon that are involved in the regulation of the blood glucose concentrations. And then the main organ here is the brain, where the hormones, the secretion of the hormones begin. So that begin from the hypothalamus, then in the pituitary gland, and then to all the other glands, respective glands in the body. Then this is just showing you how the cell functions. So from the cell, you'd find the blood vessels around the cell over there, and the tissue fluid, and how the concentrations of these particular various factors are regulated. And then, how are nutrients and wastes exchanged in tissue fluid to maintain homeostasis? So how is this exchange happening? How are they exchanged in tissue fluid to maintain homeostasis? This involves also the diffusion of these various nutrients and wastes from these particular, in and out of these particular tissue fluids and then the particular organ. Here we are depicting the pathways of tissue fluid. Number one, the tissue fluid will return to the blood capillary, and number 2, the tissue fluid will drain into the lymph capillary. So this involves the various processes here. The venule here carrying the waste products. This is the tissue fluid. So the waste product will be moving inside this venule over here. We're moving here from the tissue fluid inside. Then here at the very top, there's high pressure due to the pumping of the heart. Down there, there is low pressure due to the movement of these. Then it's the capillaries. At the very top here, you have the arteriole, which is carrying oxygen and the nutrients. So you remember, the arteriole is carrying the oxygen and nutrients. It would go in, let's say, for example, we are dealing with the lungs, the respiratory system. The arteriole will be carrying the oxygen and nutrients, moving into the particular structures involved in the respiratory system. So maybe from the down from the trachea to the bronchioles, then into the alveoli. Then through diffusion, it would then move to the capillaries that are surrounding the alveoli over there, then into the lungs. And then there'll be a vein that would carry the oxygenated blood, the pulmonary vein, which will take the oxygenated blood to the heart, where it will be pumped to the rest of the tissues in the body. So that's just an example over there. Here we are also shown the cell and how the oxygen is taken in, as well as the nutrients, into the cell, and then the carbon dioxide and waste is excreted from the cell. When it's excreted from the cell, then it goes to the tissue fluid. Then from the tissue fluid, it would either go to the venules over there, or the capillaries, or the arterioles. And then the whole process goes like that. It will really all depend on the particular nutrient and the waste product we are dealing with. The organs differ by that as well. Then the main part of temperature regulation. What actually happens during temperature regulation? It differs from ectothermic, which are cold-blooded organisms, as well as the endothermic, which are warm-blooded organisms. So ectothermic organisms, they use energy from the external environment. Hence the word ectothermic. Ecto is outside, external, ecto. So ectothermic organisms, they will use energy from external environment to maintain their body temperature. Examples of these are the invertebrates, then the fish, frogs, and reptiles. The metabolic and behavioral activity of the organism will depend on the external temperature changes. So if it's cold, then the body can't make its own heat. So it will mean that that animal or that organism will also be cold. If it's hot, then that animal or that organism will also be hot, because its body temperature is determined by the external environment. These ones here are cold-blooded. And then endothermic. Endo, we know, refers to internal, inside, endo. These here endothermic organisms are warm-blooded organisms. These are warm-blooded organisms. They use internal metabolic energy to maintain their body temperature. In endothermic organisms, the skin is important in regulating temperature. It is also the largest organ which covers the entire outer surface of the body. So if you see with all the various endothermic organisms, they have skin. That is very, very important in regulating temperature. It's also mentioned that the skin is the largest organ, so it ensures that it covers all the parts of the body, so that temperature is regulated in all the various parts of the body. We also discussed the layer of the skin and how actually it functions.
Ectotherms are organisms that mainly absorb heat from the environment. Endotherms are organisms that mainly produce heat during metabolic processes. Endotherms include all homeothermic organisms. Endotherms also include certain poikilothermic organisms, for example large fish, such as sharks, and insects. In poikilothermic organisms, the body temperature increases with increasing ambient temperature. Initially, the metabolic rate also increases with increasing ambient temperature. It then falls as a result of thermal denaturation of enzymes. In homeothermic organisms, the metabolic rate is high when the ambient temperature is low. When the ambient temperature increases, the metabolic rate falls to its basal level. Within a certain temperature range, the basal metabolic rate remains constant, even if there is a further increase in ambient temperature. This temperature range is referred to as the zone of thermal neutrality. When the ambient temperature becomes too high, the homeostatic mechanisms fail and the metabolic rate initially increases and then rapidly decreases as a result of thermal denaturation of enzymes.
That video was explaining what actually happens and how temperature is regulated in warm-blooded and cold-blooded organisms.
Ectotherms are organisms
And then this year, we'll also explain temperature regulation involving sweating and
An increase in ambient temperature is detected by heat receptors in the skin. Nerves transmit signals from these receptors to the center for heat production in the hypothalamus. This, in turn, transmits signals to the blood vessels, sweat glands, and internal organs, which start to decrease the body temperature. The blood vessels dilate, thus increasing the flow of blood. This increases heat loss through the skin. The sweat glands start to secrete larger amounts of sweat. This increases the amount of heat lost through evaporation. In the internal organs, the rate of cell respiration decreases, thus decreasing heat production. As a result of these changes, there is a decrease in body temperature, and the negative feedback mechanism again inhibits the transmission of further signals from the hypothalamus. An increase in
As explained quite briefly in the video, sweating, what exactly happens when someone sweats. The sweat glands are the ones involved in the process of sweating. They are controlled by the autonomic nervous system, which means you do not have conscious control over them. Like, you do not decide that you want to sweat, or you don't think about it. You just sweat, really. It's nothing you think about. It's something that really just happens. Ne? You also learned about the autonomic nervous system in the topic 6. Now, the temperature control center in your brain is what? The hypothalamus. Remember when we mentioned the control center, the main control center is what? The brain there. In the brain, it is the hypothalamus. That is the temperature control center. Heat is brought close to the skin surface by the blood vessels. So the blood vessels will move the heat closer to the surface. And then when the brain senses that the body temperature is getting too high, the nerves that serve the sweat glands stimulate them to produce more fluid, which is then seen as sweat on the surface of the skin. The sweat will evaporate from the skin's surface thereafter. The energy to change sweat from liquid to gas comes from the body's heat. It is this loss of heat energy that cools the skin. So because the sweat will be leaving your body, or through that liquid will be leaving your body, it will then cool down. Also, another reason that this heat here is brought close to the skin surface is to allow for this cooling down to happen. So it's not only heat that is brought to the skin surface, it is that blood. Blood is brought towards the skin surface. Then the cooling down is possible because then sweat will be released. What also happens is that when you are sweating, or when there's too much heat in your body, then your skin hair will lay down. That is a reaction that just happens. So it's not an important part in thermoregulation. It's just a reaction that you would most likely to notice. The same way happens when you are cold and shivering, then your skin hairs would stand. That is also the reaction you are most likely to note. But when that happens, then when you are feeling cold and the body needs to retain the heat, is that the heat will not be brought up to the surface. Instead, the blood vessels closer to the skin surface will be constricted, and then the ones at the very bottom down there in the dermis will be the ones that are relaxed, so that more blood moves down towards the skin or towards the body to provide the warmth that is needed. And then a summary overview of everything we've discussed today. Humans are endothermic and homeothermic. The internal environment is bathed in tissue fluid. The internal environment inside, it's just covered in tissue fluid. Underneath the skin there's tissue fluid. The hypothalamus in the brain is responsible for the greater part of homeostatic control. Like we've said, almost all or most hormones are firstly secreted from there. And then processes in the body are regulated by making use of the negative feedback systems. In the negative feedback system, a rise in concentration of a particular substance will cause a change that will reverse the situation by lowering the concentration of that substance. Negative feedback systems also work in reverse, where a drop in the concentration of a substance will cause a change that increases the concentration of that substance. That is why it is called negative feedback. It works in both ways, reverse. Ne? The blood glucose, which is the sugar, whenever you hear of them speaking of blood glucose, you should know we are speaking of the blood sugar concentration. This here is regulated by the antagonistic actions of two hormones, which are insulin and glucagon. Carbon dioxide levels are monitored by the medulla oblongata, like I've mentioned. The medulla oblongata will notice or will sense the changes in the blood concentration. When there's too much carbon dioxide, the pH level in the blood will drop. Then it will do the necessary steps to ensure that it removes carbon dioxide from the body and brings in more oxygen in the body. Osmoregulation is a function of the kidneys under the influence of ADH, the hormone we discussed here. The concentration of salts in the blood is also a function of the kidneys, directed by the hormone aldosterone. So the kidneys are involved in osmoregulation as well as the concentration of salts. Human skin has two layers. We also discussed that, which is the epidermis and the dermis. The skin is the biggest organ. It provides protection to the inner parts of the body and plays an important role in thermoregulation. Sweat from glands in the skin evaporates to cool the body down. That's why after sweating, you feel your body cooling down, because even the breeze that is blowing on your skin, whatever cool air that blows on your skin, will find that sweat over there, and it will also play a part in cooling you down. But the internal processes as well that we've explained of how it happens that you end up sweating. Blood vessels in the skin can widen, which is called what? Vasodilation. You remember vasodilation is when the blood vessels, they relax. They are widening as they are relaxed. They are dilating. Or narrow. When they narrow, it's called what? Vasoconstriction, because now they are constricting. They constrict. Why do they do that? They do that to regulate heat loss from the skin's surface. So they would dilate. The blood vessels closer to the skin surface will dilate when your body is too hot and wants to cool down. So the ones closer to the skin surface will be the ones dilating. But if your body is feeling cold and it needs the heat, then the ones closer to the surface will constrict. And then the ones at the lower, closer to the body, to the internal body, will be the ones that are widening or dilating, so that more heat is directed towards the body than the surface. And then that is it from the topic of hobby. Tomorrow we are discussing, we are doing a class activity. So I'll be asking you questions, and we hopefully please engage. Then we'll work out the answers together. If you'll be watching through YouTube, then do provide the answers. Just be ready to write down the answers and prepare yourself, so that when we provide the solutions, you can be able to monitor your progress. Work is extracted from the Solutions for All Life Sciences Grade 12 Learners Book, as well as the Via Africa Life Sciences Grade 12 Learners Book, all accessed from Snaplify. I will always sing Snaplify praises. It is an amazing, great app to use. Even if you lost your textbook, guys, listen, you don't need to go buy another one. Download Snaplify app, you get access to the textbooks for free until December. That is, after December, I'm sure you'll be paying to access the textbooks. But either way, go check out the app. It's really great. You can make notes, you can use it on your phone, on your laptop, anywhere. And the great part is, after you download the textbook, you can even use it offline. Ne? So please use these resources that are available to you guys. If it's the videos that help, use them. Whatever resources that are available, use them. They are there at your disposal to help you. We want you to pass. We want you to get those A's in your exams. So yeah, that is it from me today. I will see you tomorrow. Bye.